Okay, so now this is the formal definition of double integral. So if f is a function of two variables, so now we define the integrand here. So you are given the integrand here, and if that double integral is function of, if f is a function of two variable, okay, if f is a function of two variable that is defined on a region R on xy plane, then the double integral of the function f over the region R is given by this one. Okay, so that is the formal definition of the double integral. So now we're only interested on this, the left hand side here. So how can you evaluate that? Okay, so before we start to do some calculation, the step to obtain the multiple integral, you should know some properties of double integral. So first we have the constant multiple rule, which means that if your integrand here multiplied by the constant, let's say you have you are given double integral where there is 2 of x plus y dA over the region R. So which means that you can also just take out 2 and then just solve for x plus y dA over the region R. So also possible. And linear rule, which means that if you have, let's say, you are given double integral with x squared plus y squared dA over the region R, and you can actually split them into 2, which is to just solve for x squared dA over the R plus the double integral of y squared over the same R. So that is linear rule. You can split them. So subdivision rule, which means that sometimes your limit, let's say, okay, let's say your region, it looks like something triangle, which is the intersection between two linear equations. So your region is like this. So that is your R. Sometimes there is a need for you to split the region into 2, which means that what you have to do is just split into 2 parts. So this one is your, so this is R1, and this one is R2. So which means that the total region is the summation of the R1 plus R2. So why you need to split the region? Because the limit is different. So the limit of the integration are different. So you have to split the region into 2. So by now, of course, I cannot explain to you in detail because you don't really understand how can you evaluate that. So once we have that particular example, so I will re-explain on that. So meaning that you can split the region into 2, then you just find out the double integral for the region 1, and then find the double integral for the region 2, and at the end of your solution you have to total them up. Okay, so that is subdivision. You have to subdivide or you have to split the region into some parts. Okay, and we have the dominant rule. If f is greater than g, so the answer of the multiple integral, double integral also will be the same, where the result here always greater than the result from where the integrand is g. So that is dominant rule. And also, if the function, the integrand here is positive, so meaning that the result of your double integral also positive. Okay, so refer to advanced calculus. So I think this one is the book, because previously when we have a physical class, and last time there is a stock I mean, there is a book where the author is from UTM. They still have the stock of the book. Okay, but now I have no idea. No, there is no that book anymore. Maybe they need to revise, and I don't know. Okay, so that is about the property of double integral. And then, so this is the process of integration. So we call that as iterated integrations. As I mentioned before, if your order of integration is dx dy, so meaning that you have to settle down this inner integrand first. Okay, settle down the first inner integration. Then after that, integrate with respect to y. Similarly, if you have dy dx, so settle down for the dy first, and then after that, integrate with respect to x. Okay, so the process is to integrate is similar as differentiation, which means that if you differentiating the function with respect to x, so you have to assume that y constant, right? So similarly for integration, if you want to integrate with respect to x, so you have to assume y fixed, or vice versa. Okay. So the iterated process, the iterated integral is coming from a theorem, where the theorem is named as the Fubini's theorem. Okay, so Fubini's theorem for rectangular regions. So the rectangular region is, as you can see before this, where your region, remember I told you at the beginning, there are two types of region that we need to discuss in this course, where we call that as rectangle region, where your R is a rectangle. Okay, or you can have this one also rectangle, or we can also have non-rectangular region. So non-rectangular region, maybe you have a circle, maybe you have a triangle, and maybe you have the region which coming from the intersection between some curves where they are not straight line. Okay. Okay, so now we look at the iterated integral for the rectangular region. So in this case, how can you have the rectangle? Okay, if you have a rectangular region, why all the limits should be constant? Okay, so the idea is if all of the limits are constant, so remember you have how many limits that you have? 4, right? For double integral, you have 4. This one down here, and okay, I would say I will use here. So double integral, so for the function over the region R. Okay, so this one, if you know the limit, so let's say I use this example, dx dy. So in this case, they give that the limit of y is okay, how to read that? Limit of y is from c to d. Okay, so the outer integral belongs to y, so meaning that the limit here is belong to y, and the inner integral is belong to x, so meaning that the limit here is belong to x, so AB. Okay, so if all your limits, you got 4 limits here, they are all constant, so the type of region that you have must be a rectangular region. How can we have rectangular region if all the limits are constant? So now the idea is, we know that the region should be lying on xy plane. So you have y and then x. Okay, so from the limit provided here, now we try to rewrite into an equation. So we just say that x, okay, x from a to b, which is x equal to a, x equal to b, right? And then for y is from c to d. So from here, you can see that you can rewrite that into equation where you have x equal to b, and this one become x equal to a, and similarly this one y equal to d, and this one y equal to c. So when you have y equal to b, for example, if you have x equal to b, so what is the curve looks like? So let's say I give you an example. If I have x equal to 1, so what is the curve looks like onto the on xy plane? It should be a line, a straight line, right? So in this case, let's say the line x equal to b. So so let's say this one is a and this one is b, because there is x equal to a and b, and a should be smaller than b. Remember the condition to put the limit, so the lower bound should be smaller than the upper bound. Okay, so a should be smaller than b, so you draw that line. So okay, so that is the line that you can get from this equation. And then we go to the y, y equal to c and d. So c and d. So we draw a line. So that is d, and y equal to c. So now, which region, or where is the region that you need to shade, which satisfy all the line or curve provided? So you have to understand that your region should be closed and bounded region. So that's why you can shade, because you have closed and bounded region, region yang tertutup. Okay, so now which area on this region that you have to shade? Where the region is bounded by x equal to a and b, and also bounded by c and d. So you can see that you cannot draw outside here, sorry. So you cannot draw outside here, because this is not satisfy the curve provided, where we know that the region should be bounded by all these lines. So this is open, so this is open. They are all open except the square inside here, the rectangle inside here. So meaning that in this case, this is your which is bounded by all these 4 lines. So that's why when all your limits here are constant, so then the region should be a rectangle. Okay. So that is about the rectangular region. So the simplest multiple integral, specifically double integral, if your region is rectangle. But unfortunately, you cannot see that particular example or question in the exam. Okay, just to start the process of evaluation, I mean to understand, then it should be okay if I give you example regarding that rectangular region. But for normally for exam sake, I can't see this kind of question will be asked in the exam. But if you got that one, you're very lucky. Okay, so now if we're talking about the rectangular region, so for example, look at the example 1 here. So you are given the integrand and your integrand is on xy in terms of x and y, and your order of integration dy dx, and the limits they are all given, which are they are all constant. So we know that the region should be rectangle, where you know that y is lying between -1 to 1 and x lying between 1 to 2. Okay, so how can I know that? So you can do the similar process like this one, where you can take out the information, the limit provided here. So you can what you can have for that example, so you can have y or x. Okay, x is 1 to 2, and then y is -1 to 1, and then you rewrite into an equation. So you will have x equal to 2, x equal to 1, then you have y equal to 1 and y equal to minus 1. So now what we can say that the region should be bounded by all these lines. So now you draw, because your y can be negative, so okay, so this is y and this is x. So you have x equal to 1 and 2, and then y equal to 1 and minus 1. So now we draw the line. So I start with the x first. That is x equal to 1, and then x equal to 2. Okay, and then y equal to 1, and then y minus 1. So which area need to be shaded? Which means that where is your region? So so your region is this one. Okay, you can see rectangular region. Okay, so now how can we compute this? So just ignore the solution provided. So I want to show you here. Okay, just look at the example, evaluate this one. So the function is 3x squared plus 2xy, where the order is dy dx, y minus 1 to 1, x 1 to 2. Okay, so to start, we have to integrate first respect to y. Okay, so just to start, I will do the first integration here outside from the double integral, which means that just to explain to you what's going on, so I just rewrite that integration outside here. So minus 1 to 1. Okay, so now you have to integrate respect to y, where we assume that x is constant. So now you have to bear in mind, you are integrating respect to y, x here is constant, so x squared. Okay, now you have 3x squared, so meaning that 3x squared here, they are all constant. So when you integrate this respect to y, so the answer is, so this just like constant, so we don't change that, but it becomes, actually this one is multiplied by 1, so when you integrate 1, you will get y. Okay, that is for the first term here. Now look at the second term. So you can see the y here, right? Then the 2x here is constant, so just 2x, and then integrate y respect to y, so this y becomes y squared over 2. So we can simplify this, then you replace the value of y. Y is from minus 1 to 1. Okay, so if you are asking me whether do we need to put the y here or just 1, minus 1 and 1. Okay, for me, because it is up to you, but because of in this expression there is x and there is y, so I'm afraid that you just mix up everything. So maybe you have forgotten that actually you are integrating respect to y, so you just need to substitute the value of minus 1 and 1 only into y. But so there is a possibility that you can make a mistake. So that's why, just to notify ourselves, so it's better for you to put that the negative 1 is only belongs to y, not x. Just to remind us, okay? So now you cannot change the x because x constant, so you just replace the value of y only only for y. Okay, so the first term 3x squared, and then y is 1 plus x is x, so 1 square minus and then 3x squared, and then y is minus 1 plus x minus 1 squared. And then we simplify, so you will get 3x squared plus x minus 3x squared plus x. So when you simplify, you will get 3x squared plus x plus 3x squared minus x. So you will get 6x squared. Okay, so now the result here, you already obtained the result of the first integration here is 6x squared, which means that now you can integrate the 6x squared with respect to x, where x is from 1 to 2. Okay, so before you proceed to the next integration, you have to make sure that in your calculation, since you are integrating first with respect to y, after you substitute of the value of y provided here, and here you can see that there is no more y. But if, let's say, you can still see the y in your expression, so meaning that you've done something incorrectly. So you have to double check. Okay, so in this case, you must get the expression only in terms of x or just constant. Also possible, but you cannot have y there. Okay, so next, for the second integration, you have to integrate your result here with respect to x. So you have now 6x cubed over 3. So when you simplify, you got 2x cubed, and then x is from 1 to 2. So you can have 2 cubed minus 2 1 cubed 1 cubed. So 2 8 minus 2 16 minus 2, you will get 14. So your answer is must be a constant, as I mentioned before. If your double integral, it is related. If your double integral is indefinite integral, your final solution should be not indefinite, sorry, definite, because you have a limit. If your multiple integral, double integral is definite integral, so your final solution should be constant. Okay. Okay, now let's say using the similar example, just for exercise, and you don't need to submit, just to for your own revision, just your own reflection whether you understand or not. Can you try to change the order of integration, which means that now for the example 1, I want you to evaluate the double integral where you don't change anything, but then you just change the order of integration. So 3x squared plus 2xy dx dy. So once you change the order of integration, so the limit here will follow through, which means that now you're done for the x first, so limit of x is 1 to 2, and then the limit of y is negative 1 to y. So you just swap the location of x and y if it is rectangle, which means that all the limits are constant. But if there are, I mean, in the limit there is at least one function, whether this one can be function or I'm saying at least one, so you cannot just swap the location. It is impossible. Okay, so that is for your own exercise. how about the answer? So the answer will be the same. You will get, finally, your answer will be 14. But the way of expression can be different. Sometimes can be more complicated or sometimes can be more simpler. Depends on your luck. I don't have a specific formula to determine which one is more easier and which one is more harder and so on. Okay, just based on your experience. How can you get experience? So from your exercises. If you do a lot of exercises, then you can have an idea where nobody can explain to you, cannot explain to you, because it's coming from the idea. How can you get the idea? From your exercise. Okay, so that is for example 1.